All right, class, this is Algebra 1, Lesson 9.1, and we are classifying polynomials. So, introductory lesson to polynomials. And so, if you'll pay attention, if you have any questions, write them down, bring them with you to class tomorrow, and I'll be glad to answer them. But like any math lesson, remember the key is you need to think. So, as we go through, make sure you're thinking. I'll ask a lot of questions. Try to answer those questions in your mind, and that will get you prepared and hopefully help you to remember the material. All right, so chapter 9, polynomials. So 9.1 is classifying polynomials. Well, let's first start off with a definition. What is a polynomial? It's an algebraic expression of one or more terms. One or more terms is a polynomial. I'm going to show you an example of all of those here as we get into some specifics. Okay, so we have a special name for when a polynomial has one term. Got a special name for a polynomial with one term. And so really the key is knowing the prefix for one. So if you know the prefix for one, let's see, if you've gone to Disney World, more than likely you were on a train that went on one track, right? It didn't go on two tracks, it went on one track, and it was called a what? And I hope you're thinking of a monorail, right? So mono is one. So a polynomial with one term is a monomial. So mono, M-O-N-O, and then M-I-A-L, a monomial is a polynomial with one term. What would they look like? Well, here are a couple examples. Maybe something as simplistic as a 3x. That's a monomial. Here's a boring one. How about something as simplistic as the number 20? That's a monomial. How about something like a negative 5y squared z to the fourth? Negative 5y squared z to the fourth. Everything is being multiplied together. That's one thing. This is a negative 5 times a y squared times z fourth. That is one term. And you can even have a fraction. How about something like this? Negative 3x squared y divided by 5z to the seventh. Negative 3x squared y divided by 5z to the seventh. That is one term. That's one monomial. It's all one term. Okay, all one term. Let's get to the second one here. So what would you call a polynomial with two terms? So again, you got to think of your prefixes. And what's a prefix for two? You can think of a couple different ones. A lot of times people think die. Well, die does mean two. But how about an airplane? What do you call an airplane with two wings? And hopefully you're thinking of a biplane. And so this is a binomial. B-I-N-O-M-I-A-L. A binomial. Binomial, a polynomial with two terms. What do they look like? All right, the most standard type binomial is something like this, 3x minus 4. Here's the thing about terms. Addition and or subtraction separate terms. So if you look at that negative sign, we've got a 3x plus a negative 4. We have two terms. 3x plus a negative 4, and so that is a binomial. There are two terms. How about something like this? How about, for example, 1/3 x squared y plus 7x. 1/3 x squared y plus 7x. Do you see the two terms? Again, remember, terms are separated by addition or subtraction. You got a 1/3 x squared y, that's one term, and the positive 7x is the other term. All right, two terms. Binomial. Well, what do you call a polynomial with three terms? And you guys should be able to think of this one. Think back to when you were a little itty bitty kitty and you got on your bike that you were able to ride before you learned training wheels, and you got on a three-wheeled bike that was called a tricycle, of course, and this is a trinomial. Trinomial. So what's a trinomial? It is a polynomial with three terms. What do they normally look like? Well, normal trinomial is something like this. 2x squared minus 3x plus 4. 2x squared minus 3x plus 4. Again, understanding that terms are separated by addition, you can see we have first term, second term, third term, and henceforth we have a trinomial, right? A polynomial with three terms. And there can be more stuff in there that's possible. Maybe something like a 7x cubed minus 3xy squared plus 2y. It's a 7x cubed minus 3xy squared plus 2y. And again, hopefully you see the three terms that are there. Say, what do you call a polynomial with four terms? Do you call it a quadnomial? Well, not really. How about five terms? A pentanomial? No, not really. Six terms? A hexanomial? No, we don't do that. Seven? A septanomial? No. Octa? No. Nona? No. Dodeca? No. Really, anything past three we just call a polynomial. But specifically, a polynomial with one term is a monomial. A polynomial with two terms is a binomial, and you'll hear me say that word a lot. And a polynomial with three terms is a trinomial. Really, all of these you'll hear me say throughout the rest of your algebra career as it involves aspects of monomials, binomials, and trinomials. Okay? So you need to know what they are and classify them. That's pretty easy right there. Well, there's also a thing as the degree of a term. What's the degree of a term? In this aspect, the idea of degree brings some importance to it later on when we get into equations, because we're going to find out the fundamental theorem of algebra is that there are as many solutions as the degree of the equation. But first off, we've got to learn degree of terms, and then we'll get to another aspect of degree. All right, so how do you figure out the degree of a term? Well, the degree of a term equals the sum we're going to be adding. The degree of a term equals the sum of the exponents. So what are we adding? Exponents. And the exponents of what? Of the variables. So we're adding, and what are we adding? Exponents. And exponents of what? Exponents of the variables. That's how you figure degree. It is the sum of the exponents of the variables. All right, let's do a couple examples here. 5a is pretty straightforward. We've got a monomial. You can see that the exponent is 3, and so there's nothing else with the 3, and this is a third degree. All right, it's a third degree monomial. You look to the right, now we've got a couple different variables. They're nice and in color for you, and what degree would be B? And hopefully you're thinking 6th degree, right? Because we can all add 2 plus 4, right? 2 plus 4 is, of course, 6, and we have a 6th degree. All right, let's go to C here. All right, be careful with C. What do you think the degree is of C? You got it? All right, what are you thinking? Are you thinking 4th? I hope you're thinking 4th. You might say, oh, wait a minute, I was saying 3rd. All right, look at it for a moment. Do you know now why I said 4th? All right, don't forget, we don't show a 1 exponent, but they're there nonetheless. 1 plus 3 is 4. That's a 4th degree. All right, look at D. What is the degree of D? Go ahead and look at it. Let me give you a minute. Get something in your mind. Say, oh, I'm not going to make the same mistake from C. And you say the degree is, are you thinking 4th? If you're thinking 4th, you're not thinking correctly. It is not 4th. It's a 2nd degree monomial. You say 2nd degree? Wait a minute. The n is a 1. The p is a 1. 2 plus 1 plus 1, that's 4. Yeah, but what are we supposed to sum the exponents of? Look back at the definition here. You sum the exponents of what? The variables. You do not sum exponents of coefficients. So you're only summing the exponents of the variables, therefore 1 plus 1 is 2. All right, I hope you got that one. If you didn't, now you know, and don't get tripped up by it again in the future. All right, our next aspect is a little different though. And this one becomes important, and it is the degree of a polynomial. Not the degree of a term, the degree of the whole polynomial. Now what we've done previously are all monomials. Now we're going to do binomials, trinomials, etc. All right, so how do you figure out the degree of the polynomial? Well, it's going to equal the degree of the highest degree term. So the term with the highest degree, that's going to be the degree of the polynomial. The term of the highest degree is going to be the degree of the polynomial. All right, so I want to raise this up a little so we can see it. All right, so look at example 1. We have 3 terms, right? We have a trinomial. Okay, hopefully you agree. What's the degree of the first term? It's the second degree. What's the degree of the second term? First degree. Third one is really a 0 degree. So what is the highest? Second is highest. It's a second degree polynomial. You see how that works? Okay, see if you can do B. Figure out the degree of the, now we have a binomial, right? So figure out the degree of the first term, figure out the degree of the second term, and assign the degree of the polynomial the highest one. All right, pause if you want to. I'm going to give the answer right now. So the first term is fifth, right? 2 plus 3 is 5. And the second term, be careful, is second, not ninth. We do not count the 7. We don't count exponents of coefficients of numbers, only of variables. Therefore, this is a 5th degree polynomial. All right, and then we've got another trinomial down there at the bottom. What is the degree of this trinomial? Well, the left term is a 3rd degree. The middle term is a 2nd, and the end term is a 3rd. Well, what's the highest 3rd? And that's a 3rd degree polynomial. All right, be careful. You'll be doing that on quizzes and tests. It is important that you know how to figure out the degree of a polynomial. So be careful. Don't get confused. We have degrees of terms. For the term, you sum the exponents of the variables. For the polynomial, you figure out the degree of each term and give the value of the highest one. So be careful. 2 different aspects, 2 different things. Don't get them confused. Don't get them mixed up. Okay, let's go to evaluating polynomials. This should be no problem with us after we've dealt with systems of equations and all that. So evaluating polynomials, you want to substitute. Substitute in the value of the variables and simplify. Substitute in the value of the variables and simplify. Biggest key here is just be careful with your exponents. If you guys will follow the methodology that I show you, you should be fine. But the key is the details. And again, some of you get in trouble because you don't pay attention to detail. And therefore you end up missing stuff just because you're not paying attention to detail. Okay, so what have we done in the past? Here's the 5. Where the x squared is, I'm going to put a parentheses and put the 2. I have the parentheses in place of the x. Then I have the negative, the 3, and another parentheses in place of the x, and then the plus and 2. Those parentheses are important. Now I'm going to put the negative 3, of which the x equals, in for the x, in where the parentheses is, right? The parentheses is in place of the x. All right, I'm going to look at this and say, oh, this is an order of operations problem, isn't it? I need to evaluate all exponents first. So hopefully we all know that a negative 3 times a negative 3 is a positive 9. And that's the first term. I can now do the multiplication on the second term if I want to. It doesn't matter. And don't let that goof you up and think, well, I got to do the left to right. I got to do the first one first. You can. All right. But we're going to end up with negative 3 times a negative 3 is a positive 9. And then the positive 2. 5 times 9 is a 45. So we end up with 49. 45 plus 9 plus 2. So what is that? 54 plus 2, 56. And we've evaluated that one. All right, this next one's a little tricky, so stay with me. If you want to do it on your own, go ahead and pause the video, but stay with me here. So again, the details. I have a negative sign, and then comes the y to the fourth. So I have a negative parentheses y to the fourth. Do you see that? It's that negative and then the y to the fourth. So be careful. That's a detail, but it's an important one. I have then plus 3 parentheses for my x, parentheses for my y, and I've got to cube it. Next comes the plus and the 5, parentheses, and the y is squared, so I got to square it. All right, let's go back. I'm going to stick in my x's. There's only one right after the 3. And I'm going to take my green. I'm going to stick in my negative 2's in for that y, and for that y. All right, be careful right now. Order of operations. Right now, I'm only doing a negative 2 times a negative 2 is a positive 4, times a negative 2 is a negative 8, times a negative 2 is a positive 16 with this negative still out in front. Be careful. And by the way, class, just let me remind you, look over to the right here. I know you guys understand that if we have a problem like this, look all the way to the right. Negative, a negative 2, and I know you know to say negative and negative is a positive. So how come you couldn't do that on this one? The difference is the exponent. You've got an exponent here. You can't do this when there's an exponent. You're violating the order of operations. You're doing multiplication before exponents, and that's why it does not work. You cannot do that. You are violating the order of operations. You follow? Okay, so be careful with that. All right, the next exponent I see is down here. Negative 2 times negative 2 is a positive 4 times a negative 2 is a negative 8. So that's a negative 8. I still have my plus 3 times a 5 and now times that 8. Still have my plus 5, and now I'm going to do my last exponent. Negative 2 times a negative 2 is a positive 4. So that's where I'm at. All right, you get that, you're going to get the rest of the problem. So what do I got? I got a negative 16. 3 times 5 is 15, and 15 times a negative 8, use your calculator. This thing ends up being negative 120, and then 5 times 4 is 20. All right. I don't know how your brain thinks, but to do this in my head, if I add these two up, I have a negative 100. 100 negatives and 16 more negatives, 100, negative 116. Again, if you need to, use your calculator, but that one is 116. Be careful with the exponents when they're positives and negative quantities, okay? Be careful, be careful, be careful. By the way, the first one we did was a trinomial, right? And the second one we did was a trinomial. So we just evaluated 2 trinomials. All right, one last aspect, and that's simplified standard form. Um, Standard form can be a little bit more tricky. When you get multiple variables, there's a little bit different. There's a little bit of a difference to follow. So I'm just giving you a basic understanding right now, and we'll deal with it further in Algebra 2. All right, but the key is you want descending degree of the x terms. Descending degree of the x terms. Now, I say the x terms. It's really alphabetical order. It really is, but we're almost always dealing with x's and y's, and so, or x, y, and z, and therefore I say the x terms. Technically, it's alphabetical order, but we, again, most of the time, are going to be dealing with x's and y's, etc. Okay, let's apply this here in a couple examples. So all you're really doing is rearranging this. Okay, that's pretty easy. Put the x cubed in the front, put the negative 5x squared next, then comes the positive 7x, and then the plus 1. By the way, how would you term this polynomial? what would you call it? It would just be a polynomial. By the way, what's the degree of the polynomial? It's a third degree polynomial. If this were an equation, there would be three solutions, up to three solutions, real and or imaginary. All right, I'll talk about that later. Okay, look at the second one. So again, think of the x terms. I need my x, negative x squared in the front. What would come next? My positive 3xy, right? Oops. Don't know how that got in there. Positive 3xy. And then finally, my third term, negative 3y squared. Okay? That's a trinomial, and it is a second degree trinomial. All right, one last one here. Okay, so there's no x's, so again, you're going to follow then alphabetical order. First term, right? Negative z cubed plus z. You got to supply the plus sign there, knowing that it's a positive z, and then plus 2. There you go. Standard form, not a problem. All right. We'll work on the homework in class tomorrow. Again, the video's here. If you need to go back and watch it again, I would admonish you to do so if things just aren't clear in your mind. All right. Have a good night.